Good evening, ladies and gentlemen. Welcome to the American Club of Hamburg. Tonight we have a topic that's a bit different from recent times with all the political discussion. Nice break, welcome break. And it's in the genetic engineering and biotechnology news, they mentioned that one of the biggest threats to global health, food security and development, as recognized by the World Health Organization, is antibiotic resistance. The use of antibiotics since its discovery of penicillin back in 1928 has led scientists to predict that antibiotic-resistant microorganisms could kill up to 1.3 million people in Europe by 2050. Now, our speaker tonight, Gerry Quinn, graduated from Ulster University in 2004. He previously held research positions in Florida studying pathogenic bacteria, and in Ireland studying new treatments for bacterial biofilms. He was in Wales studying amyloid proteins in soil and streptomyces, and in Croatia studying phosphosignals which promote antibiotic production from streptomyces in collaboration with Tübingen University. In 2018, his diverse interest in botany, caves, and folk traditions led to the isolation of a group of antimicrobial streptomyces, which could combat 4 of the 6 priority pathogens on the WHO hit list from an ancient Irish folk cure based on limestone soil. He's currently based in the north of Ireland, joining us tonight, where he's interested in the identification of new antibiotics and medicines from traditional spiritual areas in medicines. So ladies and gentlemen, let's welcome Gerry Quinn. Gerry?
Thanks, David. Okay, it's quite a diverse, business, American Club of Hamburg, mixing with science. But yeah, I'll just, what I want to do is start with some background on the topic. I know everyone, we won't all be on the same page, and especially since I've been talking about this for a while, I've never really spoken to any business people, mostly scientists and press people. So I'll just start off on why we need antibiotics and why we definitely need new antibiotics. So just some horrid pictures to begin with. Has to be done. Pre-antibiotics, obviously, there was high mortality from infectious diseases right up until you mentioned the discovery of penicillin, and something like pneumonia could wipe out 90% of children infected, or leave them with really disabling or disfiguring diseases, So, the invention of antibiotics was a godsend, and things like TB was just, it wrecked whole industrialized nations and societies, because it clogged up people's lungs and stuff. So I don't want to labor too much on the horrible diseases, So I'm not going to show you any horrible pictures, but the cures at that time were quite, they were quite extreme as well. They had the kind of radioactive cures, radioactive elixirs, which will definitely kill bacteria, but they also killed people, which was a bit of a drawback. And then they had arsenic, which was incorporated in some medicine. And really that was mainly for things like syphilis and stuff, but arsenic also interfaces with the nervous system as well. And also is a really bad poison, And then they had mercury also for syphilis. That was quite common. But mercury is quite an ancient cure for things, but really the side effects are absolutely terrible, So it starts to dissolve bone and it starts to eat away at nerves and things like that, But there was actually a group of German scientists that developed something called sulfonamides, which is it's a chemical kind of antibiotic, but it wasn't really completely biologically compatible. It had some side effects, and it didn't kill the actual bacteria. What it did was it stopped it growing, And also you have maybe more relevant cures. They had iodine, which can be applied topically, and then carbolic acid, or you might know it as carbolic soap, but that can also be quite toxic, And then they had obviously traditional medicines, but to increase the professionalism of organizations like the British Medical Association. If you couldn't prove the active ingredient or the mechanism by which a cure worked, then it wasn't certified. And if you were practicing uncertified, well, you weren't allowed to practice uncertified medicine. So if you couldn't prove the scientific principles behind your methods, then you wouldn't be certified by the BMA. So therefore, they effectively banned, you know, around the UK anyway, all or most folk medicine. Okay, so you talked about the, you know, penicillin in the beginning, and most people know the story of penicillin. They might not be aware that Fleming took a 2-week holiday before he discovered it, and they said he discovered it accidentally. So here is this is the original picture from his original work. There's like some penicillin mold growing on a plate. It doesn't really look that clear here. This is the original picture, but this is, you can see the space between the penicillin, and this is Staphylococcus aureus. This is the bacteria, and this is quite nasty. It's quite a nasty organism in wounds. And I suppose, you know, I'm sure this is like an agar plate. Many people had seen this before, but it was Fleming that they kind of thought maybe there's something between here and here, keeping the bacteria away. You know, many people had kind of noticed this before, but that was in 1928. And penicillin sat in Fleming's fridge for maybe 6 or 7 years because it only lasted a couple of days. And it wasn't until 2 chemists from, I think it was Oxford, Florey and Cheney, they decided to chemically stabilize it. They had invented this thing where you add a sodium salt. That's why you see penicillin sodium derivative on the bottle, because it stabilizes the medicine. However, they only manufactured it in very, very small quantities, you know. So they actually sold the technology to the Americans, and the American companies like Merck and Pfizer and Squibb, they were you know, quite integral in developing the whole technology to bring antibiotics to the people. Previous to American involvement, in Fleming's lab, they were using bedpans to grow penicillin to extract the liquid to get the penicillin. So it was a very primitive. The Americans developed deep fermentation technology, you know, to get really industrial quantities, you know. So, but penicillin didn't kill everything, and that was up to another group in New York, actually, a group of Schatz and Waxman. And they discovered streptomycin, and streptomycin was huge, you know, because penicillin didn't kill TB. TB would hang out in people's lungs, and it was really intractable. And when they discovered streptomycin, streptomycin killed tuberculosis. Actually, the boss, which was Waxman, stuck his PhD student, which was Schatz, down in the basement with like a super contagious strain of TB. And says, well, tell me when you have something, you know. And he never went near the lab. There was no cure for TB at that time, you know. And then when he discovered, he says, yeah, well done. Good job. But the difference between penicillin and streptomycin was the boss, Waxman, he already knew people at Merck, and they had started on penicillin production. So the technology was already there. So whereas it took penicillin 10 years to come to industrial production, with streptomycin, it took 1 year of development, and then it was ready. You know, so it moved death rates from 194 per 100,000 down to 9 deaths. You know, TB, they used to have TB hospitals. You know, even when I worked in a hospital lab, they could point to old buildings and say that was a TB ward. You know, nobody went near it. You know, the cure was sunshine and fresh air. You know, because a couple of years of TB and it was game over. Anyway, sorry, I'm not meant to exaggerate sorry, I'll go back to this one, the other slide. So after they invented streptomycin, or discovered streptomycin, they discovered that streptomycin strain actually produces lots and lots of antibiotics. You know, so they'd started to look in different soils for different types of streptomyces. And even today, streptomyces produces about 50% of all the antibiotics you take, you know, tetracycline, chloramphenicol, all these different antibiotics, they're all derived from some type of streptomycin strain. So there was a huge kind of splurge of antibiotic discovery right up into the 1970s. But what they discovered about the 1970s, because they had lots and lots of antibiotics, was using the same techniques. They were discovered in the same antibiotics. And you would think, well, there's an unlimited amount of microorganisms in the world, and that is mainly true. But if they're looking in the same place and using the same techniques for the same organisms, you more or less isolate the same organisms again. So then they thought, well, you know, if we fast track all this procedure, then we can get more leads faster. So they tried an industrialized version of screening the streptomyces for antibiotics. And I'll put some figures on the screen. So each major screen cost $1 million. And GSK is GlaxoSmithKline, and they spent 7 years. So that's like $70 million just screening. This is just a screen. This is not more and more development. They got 5 leads. So this is just a classic business tale, and there was none of them worth pursuing. Okay, so that's the reason that they pulled out, and when they pulled out, quite a few other major drug companies pulled out of antibiotic development. So really, just now, I don't think there is any major company, although they might be getting back to it with this pandemic just now. But there is a need for new antibiotics, and the need for new antibiotics is because of antimicrobial resistance. There hasn't been an antibiotic on the market that an organism is not resistant to, you know. And with the days of fast travel from one end of the world, from Japan to America, or from America to UK, you know, somebody could always bring a strain, you know, a resistant strain. So, you know, the amount of antibiotics we use, they thought antibiotic resistance was a new thing because we use too many antibiotics. But some people in Mexico discovered some antibiotic resistance organisms in a cave that was 4 million years old, as in 4 million years before the outside environment had touched it. And they found antibiotic resistant gene clusters, which means that the organisms use the antibiotic resistance against each other, if you know what I mean. So if you're an organism and you produce antibiotic, you have to have protection against it, okay? Otherwise, you self-kill yourself. So other organisms also develop that resistance, and sometimes the bacteria swap genetic information between each other. They say, oh, that's a useful piece of antibiotic resistant gene, and they swap it between each other, and then they become resistant. But some organisms obviously do that more often than others, and they are the successful pathogens, okay? So the World Health Organization had made a group of 6 common hospital pathogens which they target for new antibiotic discovery. Okay, and these have been the top of the list, you know. And, you know, what we do just now is chemically modify existing antibiotics, okay? But what the antibiotics really need is a new backbone structure, because there's only so many chemical modifications you can make to the outside of the structure, okay? And it's easier for an organism to develop antibiotic resistance to a small modification, okay? So I hope I'm not losing anybody. So what we've had for a long time is just mass replication, but now it's down to smaller concerns to invent, you know, newer antibiotics or discover new antibiotics. So they're all looking for innovation. Okay, so innovation is the key word in antibiotic development. So a lot of people think that nature is the greatest innovator because it's had the longest experiment and the most amount of failures and the most amount of successes as well. Okay, so people have been now looking to the natural environment, okay, for new antibiotics. You know, there was a couple of early tries with frog venom from Michael Zaslov. I think he was in America somewhere, and he was trying frog antibiotics, but they never really took off. And then, but there's current tries with ants, which farm, supposedly, they farm Streptomyces in gardens and to kill off, pathogens around them. And then there's been some recent successes with snake venom looking, but the most hits actually come from natural medicine. So this field was really pioneered by a man called Geoffrey Cordell, who was looking for anti-cancer compounds. And he found out that he actually get more leads from traditional medicine than he would have just searching through plants. And that obviously saved him a lot of time. So other people, obviously I'm not the only researcher in this field. There's other people in Canada. There's a famous group from Julian Davis, who's very big in antimicrobial resistance. He discovered, he didn't discover they got some indigenous soil recipe from the Celtic people, and they found out that actually beats a lot of antimicrobial pathogens. They have been taking this clay and then kind of rubbing it on their skin for, they say millennia, like thousands and thousands of years, and they still not developed resistance to it. And they went further on to discover that some of the abilities of this clay was due to these Streptomyces bacteria. There's also been other researchers in Jordan. So when I was in Wales, I was working with, my boss was doing a lot of Streptomyces research, and he was looking around the world for places where he could isolate new Streptomyces, like the Brazilian rainforest and Tibetan plateau and the Gobi Desert. So when I used to do botany, I'd done a lot of botany around Fermanagh, and I identified a lot of alkaline plants, and that was one of my favorite things, because they're quite rare. Alkaline plants are quite rare in the north of Ireland, maybe not in the whole of Ireland as a whole. And so I knew that the nature of the soil was alkaline, and I thought that maybe we could isolate. The theory is that if you can isolate an exotic Streptomyces, you might be able to isolate an exotic antibiotic as well, because they produce exotic. So I decided to look around Bow. So it's Bow, not Boho, and Fermanagh, which is about 3 miles from the border, is near Belcoo and Black Line, near the Loch McNean. Okay, and this is a limestone area with a really, really high diversity of plants. So it's got a really rich floral history. So here's just the beginning of the escarpment. So it's not really mountains as hills as such. And they overlook the surrounding countryside. So it's limestone. So the limestone supposedly is derived 300 million years ago when it rose out of the ocean. So these are actually, in the fossils, these are actually sea plants. You can see they're called crinoids, so they rose out of the ocean. But that's a bit of a diversion. But obviously limestone area has a lot of caves, limestone caves. Limestone caves also gave me a clue, because there's been a lot of research on isolating Streptomyces from limestone caves. And also I used to do some caving, so I was quite fond of caves as well. But it's mainly, the area is mainly grassland and it's agricultural. There's very, very, very few people, okay? And also the area has got a long history of habitation. It's got many, many Neolithic remnants that the farmers don't even know about. The one down the bottom here is, you can see this is a Neolithic stone that's found near the cure. As you might see, I don't want to go into this too much, but this is called Cup and Ring. It's got Neolithic signs on it that are found in places like Newgrange. Okay, so I said a high diversity of plant species. I used to be a botanical surveyor, so I'd go around and identify grasses. So that sounds really interesting, doesn't it? This one here is called Quaking Grass at the top. I'm not going to go through all of them. Sorry, my pointer jumped there, but I like this one because it's called Quaking Grass. It's just an alkaline grass, and this one's bird's foot trefoil. And there might be different kind of German names for them, but I like, when I was botanical surveying, I like to see different plants, you know, because, okay. So I wandered around, Bo, and took lots of soil samples, because I knew this kind of soil would be good for isolation of Streptomyces. And then we done some kind of rough screen. So this is just me plating the organism out. What you do is you make some agar, which is like a gelatin, but agar is non-digestible to bacteria, well, most bacteria. So therefore you can grow some bacteria on top of it. But the main thing to watch out is the Fleming moment. You can see some bacteria here, well, they're all bacteria, but here you can see halos of inhibition. And this is what we look out for. You know, this gives us a clue. And then we home in and we try to isolate these particular bacteria. And then we do further tests. This is just like, you know, this is not even a screen. It's just a rough, I get a magnifying glass and look and see, is there hope? Isn't there hope, you know?
And Gerry, these are based on scrapings from that soil there that you drop into the little petri dish?
This is like a hundredth of a gram plated out on a plate. You know, I dilute it in water, and then I take some of like a micro amount of the dilution and swab it onto a plate. I mean, it's, you know, sometimes I dilute it 1 in 100, 1 in 100, 1 in 100, and dilute it out, because obviously there's lots of microorganisms in there. So you don't want to be swamped. You won't see anything, you know.
Mm-hmm.
Okay, let me see. So in looking at the soil, I hadn't really thought about, you know, the history of traditional medicine in Bow, you know, in Fermanagh. And I started to investigate a bit and try and join the dots of the history of the church. So the cure, or the tradition I was following was it was called the soil from Father McGirr's grave, okay? Which I thought it was a bit strange and maybe verging on sacrilegious for people to take a bit of clay. You know, they did return it, you know, but I just thought it was slightly weird. But then I found out that the church was actually built on a previous Druid amphitheatre. So before the church was there, the Druids used to have an amphitheatre there, okay? And then before the Druids, they had these Neolithic stones, which are just a couple of 100 meters away from the grave. So, you know, if you look at where the church is, you maybe not see it here, but this is overlooking the whole countryside. You know, it's in a very, very prominent spot. You know, so I began to think there was some kind of, you know, around the area of Bow, this is a general cure, but there are people who hold cures for various things, but they're not allowed to give it away. You know, it passes from father to son or father to daughter, or whoever's the most reliable person in the family. But usually it's a secret. They're not allowed to give it away. They're not allowed to charge money. They're not allowed to adulterate it, and they can't tell you the secret. You know, I think that's to keep it, you know, just uncorruptible, you know, or incorruptible. And they're not allowed to profit from the cure itself or gain power or whatever it is, you know. So, but this particular cure in the graveyard is just a general cure, and that's what makes it so different. Okay, so when I when I was young, I knew some people that might have been relations of mine who had cures, and I used to spend a lot of time badgering them to get the secret from them, you know. But it never ever worked. I didn't realize that years later I'd be, you know, actually looking to see what the real answer. But when I was young, you know, the people that had cures, to me they were just magicians, and I really wanted to find out what their secret was of curing disease. Anyway,
well, how would they apply those cures? Do you know about that?
Well, sometimes they'd make potions with soil and herbs and different things, but unless you had the disease, you didn't know. They wouldn't tell you. I did at one point, so just because I know you're going to record it, so I don't want to say too much.
Okay.
But you know, somebody had a disease close to me, you know, and it might have been a pretend disease to see what the cure was, you know. but it caused a whole load of, because it's meant to be treated seriously. It's not a joke, so if you trick somebody into coming down with the cure and you don't have a disease, there's a follow-up, so I done that when I was young, but there was a follow-up. So no, I didn't actually know what they were doing. They just had that hidden beside them, Anyway, so the Druids were quite into healing, and they were referred to as thaumaturgists, and thaumaturgists are miracle workers. But Father McGirr, so he was an interesting character because he came out after the penal laws. He was on the cusp of coming out or being a priest when the penal laws finished, as in the ability to practice your religion, and the ability to preach in the open, So, but he knew a lot of the folk healers around the area anyway, and he was also referred to as a thaumaturgist, a miracle worker. But really, what I think he was just, he just knew some of the folk culture and the folk medicine. So that's where the cure originates from, because he said that the soil that covers him will be able to heal people when he dies, because they were worried that once he went away, there'll be nobody to cure, various ailments, and he says, don't worry, it will be in the soil. So, I think a lot of people took him literally, and in the great Irish tradition of taking things literally, they even up to my mother's day, they still took pieces of soil, for various ailments, and then brought it back. And they had a whole ritual of, taking the soil, going home with the soil in the cloth, not saying anything to anybody on the way, and applying the soil or keeping it underneath a pillow, So when I was investigating the cure, I was going around a lot of people I knew or relatives saying, well, what do you know of the cure? And they all be slightly different. So, I would try to piece together. I'm thinking, okay, what's the wheat and what's the chaff? What's this bit about not speaking, and what's this bit about toothache? And try to work out what was in it. But eventually, I just grew some of it on agar plates, and we isolated a Streptomyces. Well, we isolated about 8 or 9 Streptomyces because by then I had developed my Streptomyces isolation technique. So this here is what we isolated. This is a quite a mature Streptomyces. It grows like a fungus. It's a bacteria. I know, strange, but it grows in this. I don't know if you've ever seen mushroom circles. It grows and then it dies, and then it grows and it dies and it grows. So it goes through cycles, but every time it dies, or every time it goes into what do you call it, secondary metabolism, it starts to produce some antibiotic. So every time it's reached its full maturity and it goes to the other stage, then it starts to produce some antibiotic. So we went through a whole, I isolated the DNA, and then we sequenced it to see if it was, similar to any other species. We found that it was a brand new species. Okay, we found that it was extremely pH tolerant, and also with limestone, you tend to get a bit of radiation, a bit of radon gas, kind of seeps out, So I was able to test some of the radiation tolerance in our institute when I was working in Croatia, because they have a particle accelerator underneath, and radiation equipment and all that kind of stuff. So, but the most important thing was it produced antibiotics, and it produced antibiotics against a lot of different organisms. I'm just showing some of the organisms here. So, as I said in the beginning, there's 6 main organisms that are common multi-resistant organisms, and multi-resistant organisms are organisms that resist a lot of antibiotics, and they develop a lot of antibiotic resistance. So you might have heard of the first one, methicillin-resistant Staphylococcus aureus, or some people know it as MRSA. Okay, that's quite common to people. And then when you get even higher, vancomycin is actually a more powerful antibiotic. So I was able to kill vancomycin-resistant enterococcus. Okay, so, and carbapenem is another step up. This is the most super penicillin out just now. Okay, But there's also some organisms that are resistant to carbapenems. You know, these are some of the most strongest antibiotics. So I was also able to kill carbapenem resistant Acinetobacter baumannii, which, you know, is some feat. So you probably see these zones up the top. Really, the top layer is what I do is I cut a piece of this agar, okay, without the organism, and then I sterilize it slightly. But this will still retain all the chemicals of the antibiotics coming out from the organism, okay? And then I place it into the agar, okay? And then I cover it again with another layer of agar, but it has a pathogenic organism. So if the organism contains antibiotic, it will make a zone of inhibition. So here's a zone of inhibition, okay? And you can see that it's quite, so every time I do a test, I always do the bottom row is a control test. I always test it against control antibiotics, okay? Just to make sure it's not every experiment has a control, you know, just that's the way science goes, you know, or that's the way logic goes, actually, just to make sure it's not a mistake. So that was, and then, you know, I have been uneasy because, you know, there was a lot of controversy generated around, because it was a small folk cure. And then, you know, when the news that it had some scientific credence took over, then it was the weeping statue effect, where people just came en masse to get a piece of soil. So there was lots of worries, you know, and there was lots of exaggerations. So, you know, in order to calm that down, I had over talked the mention of radon gas just to keep people away, you know, just so that it wouldn't build into such a big episode. But you know, you can't help people wanting cures or wanting to be helped or all that thing. So, but it's not really an exploitable resource. You can discover some organisms. I have them in the lab. That's okay. I don't need any more soil from there. But what we did is I went further up the mountain and looked in other places, because I realized, you know, that the folk tradition exists all over the mountain. It's not, you know, in the graveyard is, you know, maybe a mix of superstition and whatever, but these organisms exist all over the mountain. So I just went to another place and done my isolation technique again, found some more organisms. But really what I was looking for was, you know, I always try to make the pack, you know, I want something that's going to kill all the organisms, you know. But if you have something that kills everything, it might be toxic to human cells as well, you know. That's the other problem. It might go the whole other way. So, but I did recently, I published something in December where I isolated another organism, which has a broader spectrum of activity, but it doesn't kill everything. Okay, where's my wee pointer? Doesn't kill E. coli. And that's probably not really that significant for anybody, you know, apart from microbiologists, but E. coli lives in your digestive tract. It's a marker of your, you know, it's a coliform. It exists in your intestine, but it doesn't kill it, which means it's not super toxic, you know. So this is like my latest discovery, which I want to move forward with this as well. So, but you know, the point of my whole talk is that I've been able to pull out, you know, several leads from natural folk medicine, okay, on a very, very small budget, you know, which have proven to be effective against 4 of the most common multi-resistant pathogens, you know, worldwide. You know, so for me, the next step is to identify some compounds, okay, before further clinical trials.
Can I just ask, it says effective against 4 of the most common resistant pathogens. Does that mean the existing antibiotics out there are not effective against them? Is this going somewhere the others aren't?
Antibiotics work in tiers. Okay, so you get the bottom tier, which is the least toxic and the cheapest tier. Okay, it's things like penicillin, ampicillin, and other things like that. They're the cheapest, most effective. Okay, if the organism is, and most antibiotic resistant organisms will be resistant to them. And then there's a second tier you move on to, which is a more developed antibiotics, and then there's a third tier, and maybe a fourth tier. So, but once you get to the fourth tier and there's nothing left, okay, then you're in real trouble. Like something that's carbapenem resistant, like I said, and carbapenem resistant. So carbapenem is the top line.
Okay.
Just now, so if it starts to get resistant, then there might be other things that kill it, but you start to worry because there's nothing on the shelf, and that's really why we have to have you, because really there's been maybe 10 or 20 antibiotics since the 70s, and that's not a lot. You want to fill the shelf. The new mode is to actually use for really resistant organisms is to use a combination of different antibiotics so that it never becomes resistant to one. Things like TB, they use a combination now of antibiotics, maybe 3 or 4 are recommended. And the same technique worked, I'm shifting to viruses here, but the same technique here worked for viruses. Use a combination of therapies, okay, so that it doesn't build up resistance quick, because they knew with something like HIV, if a virus or something builds up resistance quick, then you're in big trouble, especially with a lethal infection. It's not so bad maybe with a minor skin infection, but definitely some of the Staph aureus are, you're in big trouble, or the Acinetobacter baumannii, you're in big trouble. So, but given the current situation, I've actually started to also move to antifungal antibiotics. And antifungal antibiotics actually linked to there's some original research that's kind of long forgotten about antiviral compounds. So I'm kind of moving into that area. I'm doing preliminary experiments, and that looks quite promising. And that's it.
Well,
I have some other slides, but they're like complicated. In case anyone asks me any complicated questions, then I'd hit them with some complicated slides.
I think Niels has a question.
Niels, are efforts to chemically isolate some of the compounds, but if the compounds are not in the databases, then we have to move to another. It's called nuclear magnetic resonance. To actually structurally identify the compounds. So that's kind of the stage we're at. We're at the bedpan stage, of pulling out the antibiotics, So this slide here is just a summary slide of isolating the bacteria, screening it. We call our new technique clean extraction. I've been developing clean extraction technologies because these things here, they'll secrete thousands of compounds, okay? And there's no point in examining it once unless you clean up the compounds. So we've kind of developed that. I can't tell you just now what we've done to do it, but we've kind of developing clean extraction technology, and then we use our knowledge, because we can screen the DNA of the bacteria relatively cheaply, and there's whole databases to give us a clue of what antibiotics might be there as well, so we match that up with our chemical identification to make better identifications. But I don't want to throw too much at you too soon. And these are just 3 of the recent papers we published on it about antibiotics from traditional medicine, really, So that this one here down the bottom is let me see, that was December, was it? No, July. No, this one was December. This one here, sorry, just my most recent one. It just went online a couple of weeks ago. So, okay. Right.
Okay, would you like to take some questions now? I know Niels has a question for you.
Increase the screen.
I would actually like to go one step back, because I think I understood quite about everything you said in the popular way you put it. So thanks for that. I think it's really exciting stuff that you're doing there. But other than just saying that people put some soil into their pillows, what was it? What they actually use this for? Like hundreds of years, this dirt. Did they put it in a glass of water and gargle with it?
No. Streptomyces hate water. Well, they don't hate water, but they don't really like water. They like kind of like a dry condition. But what they did was they spooned it into some cloth, some cotton cloth. Then they brought it home, and either they put it in their bed, you put it underneath the pillow, or beside them, beside the wound. That's as much as I know.
What did it help against? I mean, was it?
Wound infections, fungal infections, and toothache, which I don't really understand just now, but you know, the bacteria does give off a really pungent smell. You know, there's a lot of researchers just now doing research into the volatilome or volatile compounds given from Streptomyces, which might be antibiotic as well. So this particular bacteria smells a bit like incense or something. You know, it's got very volatile. You know, after it rains and you can smell the soil, that's Streptomyces volatiles. You can smell that earthy smell. That's Streptomyces. There's like, I can't remember, like 10% Streptomyces in normal soil anyway. So that really earthy smell, that's the volatile compounds. It's the secondary metabolites from Streptomyces just being released, you know. So, but the one I discovered has a really, has a more incense type smell. Some people describe it as a wintergreen smell, but yeah, I don't know. Our noses must be different, but I think it's more like incense. And that's why we gave it the name Myrophoria, you know, because it smells a bit like, you know, myrrh or something, you know.
Okay, did that answer your question, Niels? Or?
Yes, it did.
Okay.
Well, you know, I mean, sorry, getting the because this is another point. All the very old people they're dying off. You know, the people that remember this, you know, the cures and stuff, and this part of Ireland, they're disappearing. You know, it's a very much a fading, you know, it's a very much a fading thing. There's I don't know. I know maybe one person who has a cure, or maybe two in the whole area, you know, now, and I think, you know, it's failing, you know. It should have been, you know, there was a big attempt in 48 by the Irish government to document a lot of this, but it wasn't really that scientific. They created a lot of journals about, you know, the book. There's a group in Trinity College kind of followed up, you know, but it's kind of lost in some, you know, like Irish history is kind of lost in some mythology. You know, it really needs somebody to, you know, I never throw anything out. If somebody mentions something ridiculous, I might put it to the side, but I don't discount that something in there might lead to, you know, better knowledge of what's happening. And I'm really, although the people now say you take some soil, you bring it home, I'm not sure if that's the real thing you do. You know, I'm not sure if that's a proper way to do it. You know, we have been experimenting with, you know, does antibiotic adhere to cloth in the lab, which it does because it's an organic substance. You know, does Streptomyces like cloth? You know, I've been doing all those kind of things, and it does like cotton. Streptomyces, you might see on the side here, Streptomyces arose also around 300 million years ago with plants because they degrade plants. They degrade really tough fibers like lignin, you know, or cotton, you know. So I've been quite interested, but I really, because there's not much written information, it's more like written as a folk story. It's really, really hard to penetrate the mythology and get in at the actual roots of really what's going on, you know. Grain of salt, I would say. You have to take it, but I have been experimenting definitely with cloth and Streptomyces, with the adhesion of volatiles to the cloth, and then seeing if it's antibiotic. and various combinations of that. But I'm not so sure that the modern interpretation of what they've been doing for thousands of years is maybe correct. I don't think so. And the modern interpretation, some of them wrap it in plastic, which I'm pretty sure is not right. But
Okay, Gerry. We go from Niels to another Niels Peterson. Go ahead, Niels.
Hey, thank you for the presentation. I got a rather more in the pharmaceutical direction heading.
yeah.
What are the chances that your discoveries will raise interest in pharmaceutical companies, and how long do you think would it take until it goes into production and gets its approval by the federal medical associations?
Yeah. Well, I'm racing against Fleming. He took 9 years, didn't he? I've had some interest from America, but it's animal veterinary medicine. So now that it's becoming more difficult to give animals veterinary medicine like antibiotics directly, they're kind of maybe thinking of not cutting corners, but doing it another way by introducing antimicrobial producing like probiotics, like you get a probiotic and you eat it and it's meant to help your digestion. Well, they think probiotics, but produce antibiotics, feeding it to various cows. But the thing about it is my organism quite likes alkaline conditions. That once you go down above below 6 or 5, pH 5 or 6, then it doesn't really like that for producing a lot of antibiotics. But it doesn't mean to say you can't isolate antibiotic organisms at that pH. I've had some interest, but it's kind of petered out, definitely during the virus period. It's all virus. I haven't been contacted by anybody. And that's kind of why I'm getting into antiviral tech. But I know there's antiviral compounds in there. It's not, but antiviral compounds from Streptomycin started off a bit toxic. So I need to figure out, are they toxic first? That'll cut a lot of work. But how long? Well, I suppose once I get some NMR or some crystal structure on the active ingredients that I've isolated, then I'll move faster. But in terms of years, yeah, I don't know. It depends, because there are other people doing this, and I haven't been picked up, so to speak. I've been picked up by animal veterinaries, and they said, yeah, we can develop something, but they've got a whole range. They not only Streptomycin is used, they're using things like Bacillus, which is a really hardy spore forming organism, but it also produces some antibiotics. So they're thinking about introducing Bacillus into an animal environment to keep them healthier. So I couldn't give you a timescale, but the usual timescale is like 8 or 9 years, something like that.
So you won't be Fleming on this.
It should be faster these days. Well, but think about it for the world effort for COVID virus. Sorry, I keep mentioning it. But how long was that? I mean, a worldwide effort before even a vaccine was 8 or 9 months. So I'm a very small fish in a big pond. And also developers have to see the money in it. I mean, this would be a very high-end antibiotic, but we need lots of them. We need lots of them for the top of the shelf. But it would only go to the person with the severest disease, with the most resistance, which isn't that many. The disease might be common, but if you get to the top of the tree, there might be one case that's needing it. That doesn't make a lot of money either. But that's not. I'm not obviously in it for the money. I'm in it for the egotism. No, I'm in it for the, discovering antibiotics, obviously, because I'm very interested in it. But somebody put that point to me. But we need to build a reservoir, not one, not two, but we need to build a reservoir of hundreds of antibiotics so that we don't reach this stage again. And I used to work on antiviral technology. That's the same for the virus as well. We need to build a reservoir there's been lack of investment in research, and that's why only the small people are doing it. And if we have a reservoir, it's easier to pull on the reservoir in times of trouble. You know, we won't reach those stages where everyone was all locked down and for TB or something as a way back in the past. You know, we'll have something to pull upon, you know, in times of trouble. But you know, not everybody has that foresight to see a way in the future and go, oh, there's going to be a crisis and we need to prepare. So you know, we can all be saying, oh yeah, you should have done that. But since I've been in research, then that's always been the problem about not much interest from people, you know. So
Thank you.
Gerry, since you mentioned that the cures is sort of a dying tradition, my sister just chimed in, who lives in Ireland, and she wanted to also just talk about her experience with a cure. Sylvia?
yeah.
Yes, this is going back maybe 20 or 25 years ago. I got a sprained ankle, and a woman who lived right up the road from me had the cure for sprains and strains. So I never heard of such a thing. But anyway, I went into her house and she made me a cup of tea and gave me a piece of scone bread. And she went in the other room and she came out with a length of twine.
Right.
You know, it was a light brown, it was twine. It wasn't rope and it wasn't string because there were fibers coming out of it. And we just talked about the weather and what was new. You know, it was just a casual conversation. But all during this time, she was working the twine in her hands.
Right.
And then she tied the length of twine around the ankle that was so swollen and sprained.
Yeah.
And she said, don't thank me.
Okay. Yeah. That sounds right.
She wouldn't take any money. She wouldn't, you're not supposed to thank her. I don't know if it goes for all people who have a cure. I would assert that you don't say thanks or give them any kind of donation or monetary.
Supposedly you can't give them anything. Yeah, that's right.
No.
Yeah.
Anyway, the next day, I forgot about it then. The next day, the twine was gone off my ankle. It was not there.
She left the twine around your ankle?
She tied it around my ankle.
Right. Okay.
She knotted it around my ankle. And the next morning, I went to look for it and it wasn't on my ankle.
Right.
And I took the bed apart. I stripped the bed. I shook out the bed. I checked the floor. I looked under the bed. There was no twine.
Wow.
And that is a true story. And the swelling was gone and the sprain was, and I was able to, because that evening we were actually going to a 21st birthday party and I danced all night.
You had to dance, yeah. Yeah.
And how I got the sprain is my own horse stood on my foot and she wouldn't get off. And she moved around and I was struggling to pull my foot out from underneath her hoof. But it was on an incline, so I was lower than she was. You can't really push a horse. No. But that's how I sprained it. And I also have, I don't know if you have heard of this. Are you familiar with Garton Lake?
Garton?
Garton, Gartan. It's on the way to Glenveigh National Park.
Yeah, I think so. Yeah.
Okay. This little packet is Garton clay.
Oh, really? Oh, stop it. You shouldn't have told me that. I'll be all over it.
You can only get it from the family.
Oh. No,
it's the Friels. Their last name is Friel. Now, one of the Friels gave this to me. I cannot give this away.
Right.
You have you can only, it's only accessible through the family. So
Right.
what this does is it prevents sudden death, drowning. It
I need some of that.
cures your, it also prevents fire in the
Right.
house. So a lot of houses here in my area have garden clay in their house,
That's weird.
and I
Yeah,
keep it
so-
at the front door. Now,
Yeah.
it's called garden clay, but as you can see, it's white,
Right.
and
That's
it's
interesting.
chalky like the cliffs of Dover. It's
Yeah.
what is that, limestone?
Well, it'd be, I don't know what it'd be, but chalky sounds like alkaline or something, you know.
It's well, I've been to the
Streptomyces
cliffs of
territory.
Dover. I've been to the cliffs of Dover, and
Right.
it's chalky like that. That's
Mhm.
what this is, very chalky like the cliffs of Dover. So
Right.
this is wrapped. What they've done is they've wrapped it in a little bit of probably cling film or saran wrap, and then wrapped
Right.
the tape around it. But I wouldn't be without this.
Okay, well. Well, you can give David your email address and tell me all about it in an email, and he can give you my email address, you know. And well, you know, the problem about these things is it takes a whole load of figuring out. For that would keep my brain busy for a year trying to figure out what's going on, you know.
Well,
Definitely.
look, I never heard of garden clay until I moved here. I absolutely would not be without it. And again, you see, I moved house then, and my garden clay was misplaced somehow, even though it's something that is so important to me. But anyway, look, somehow I misplaced it, and I made darn sure that I got a fresh supply.
Right. Well. So
I wouldn't be without it. So there's two little things. Now, I recently, but just about 2 weeks ago, I sprained my ankle again.
Again?
I fell. I went over on, I had been sitting on the couch knitting a blanket, and I went to stand up. And what I wasn't aware of was that my foot was completely dead. I didn't have any pins and needles, but there was nothing. So my ankle went underneath, my whole weight went down, and I fell into the Christmas tree. It was when I had the Christmas tree up, and I put a big hole in the Christmas tree. And I see the woman who gave me the cure originally has since passed away. She has passed it to her son. It's to the next generation, but it has to be to the opposite sex.
Oh, right. Okay. Yeah. Okay. Yeah,
so Jim has the cure for the sprain now, and he has 4 sons and 1 daughter. So he'll have to pass it to the daughter.
To the daughter, yeah.
And
thank
then,
God he's got a daughter.
Yeah, I know. Well, look, I would say in that case, he could pass it on to his sister, because I think he has about 5 sisters or something like that.
Okay.
But it has to skip. It's the opposite sex.
Right. Yeah.
It gets passed from male to female to male to female like that.
Yeah, I've heard something like that, but I just wasn't sure if it was male to male.
No, well, you did mention that in your talk, but in this case, it's the opposite sex.
Right. Okay.
So I just thought I would throw that in.
Yeah, well, I'm just mind blown now.
It is. Well, it's fascinating. I suppose it's significant if you believe it is.
Yeah. Well, I think Lawrence wanted to ask something. Did you, Lawrence?
Pardon?
Was it? Lawrence wanted to ask something.
Lawrence? Oh, I don't know.
Yeah, there's somebody raising their hand.
No, I think we got that already.
Eh?
I don't.
Yeah.
Lawrence, go ahead.
Yeah, Gerry, on your timeline, I can't see the influence of the leprechauns. When did the leprechauns come into it?
They didn't have leprechauns in Fermanagh. They had fairies.
Oh, okay. could.
Not leprechauns.
Oh, okay. Now I have a couple of questions that I'm just curious. If I just say them very quickly, they're very short questions.
Yeah.
You said in your area of development or experiments in your research, there's not much done. Actually, you know, you remember in the old days, the science fiction films and a lot of information about warfare. So, you know, one of the themes was germ warfare. So I would have expected the military is in this area of development quite knowledgeable. And it was always, you know, what was an alternative to destructive forces, the atomic bomb and things like that. The materialistic area or values would be, you know, not harmed, only the human beings would be eradicated. So the other second question was something about outer space, you know, the life in outer space. And a lot of that has to do with bacteria and viruses and things like that. I think they've discovered different bacteria in outer space or the probes or things like that. Do you have any information on that? And the last one was actually on your timeline, a comparison between, you use Druids, but you know, I think immediately of in America, the Navajo, the Hopi, the medicine man, you know, in comparison as a parallel, or in my home country in Australia, the Aborigines, a lot of their corroborees also have a lot of magical and traditional medicine involved in the passing down of tradition or of knowledge. So that was a comparison. Did you research in that area or make comparisons with that also? Or is that you've got enough to do in the area that you're researching at the moment?
Well, you know, I'll just address the major point first. Getting something to do with traditional medicine published in a serious microbiology magazine was a feat in itself, which I had to decrease my emphasis on anything traditional and just do the hard science, you know. And I read in a Twitter feed the other day, there was somebody complaining about my article. He says, oh, they haven't put enough traditional medicine into it. And one of the reasons, the other reason I didn't put a lot of emphasis on the folk cure was that any miraculous happening in Ireland, there's an automatic flock of people, you know. I had to go and see the clergy first before I even published and say, is this okay? But you know, that wasn't enough because it just developed into like a snowstorm. But I had to try and make sure, but the roads were jam-packed on a tiny rural area. It was just full of people coming up all the time to visit this grave. But I was trying to look up folk traditions, but you know, the only folk tradition I know is from personal experience of knowing people that have the cures. The documentation of people in rural Ireland is very Spartan, very, very Spartan. So I only know particular people that have particular cures, and cures for stuff that I'm like, how does that even work, you know? But you know, I don't close it down, you know, but I know that for instance, Streptomycin is not only responsible for antimicrobial activity, but it's also antifungal, and it's also anti-cancer, and it's also anti-parasitic. And they were also trialing some, I think it was ivermectin on antiviral stuff, you know, recently. It was a guy from actually Donegal. They got the Nobel Prize for ivermectin, a guy called Campbell, I think, just 5 or 6 years ago. But some of the more, let's see, claims not based on believable data is, you know, it's hard for me unless I can grasp some actual data. You know, the just briefly on the outer space thing. I knew somebody would do something outlandish, but I think what they found wasn't actually bacteria. They were looking at some primitive remnants of some amino acids, or what they thought were amino acids. But what I thought when they were doing that research on the Martian amino acids, well, I thought, yeah, it's a bit thin, you know, because it wasn't an actual amino acid. They were saying it was a proto amino acid, and carbon, nitrogen, oxygen. Yeah, I don't know. I'm not an extraterrestrial biologist. So I thought it was quite thin. I need to see more evidence, but with the cure just now, I can see streptomyces, bang, you know, antibiotic activity, bang, straight away. I can see it in the lab. A lot of people were trying to replicate it and say, well, if I take a piece of soil, and that's not how it's done, you know, not in the lab. You know, we have special conditions and special nutrients, and you know, we have special ways of monitoring the bacteria to make sure we can see what's happening at every part of the process. But we simplify the process. You know, once you get to a complicated process like a whole soil and a whole organism, there's way more variables that, you know, there's so many to measure. You know, what was the other? What was your first part? Your first question?
It was relating to scientific research from the military in the areas that you're involved in. I would have thought, you know, in germ warfare, that would have been covered quite extensively.
Oh yeah. Well, supposedly there's a moratorium on any germ warfare. You know, well, I used to work with some HIV research as well. You know, but I knew from those days that there was a moratorium. Nobody's supposed to be doing any apart from defensive capabilities. Because I did some work in Florida, and as far as I know, the last attempts, even the stocks of smallpox virus, the Australians were one of the last people to experiment on. You know, they said in case anyone makes some deadly smallpox, and they mutated their smallpox something like 19 times to accidentally build a really, really deadly smallpox. But then there's only two countries in the world that have stocks of smallpox, which is Russia and America. And they came to the Australians and just confiscated everything and says, no, you're not allowed. And that was the last thing I mentioned, but that was something like 15 years ago or maybe 17 years ago. But I do know that the governments don't tell people everything, you know, because then you raise your surprise element. And I do know that there are institutes for defensive research, but I don't pay too much attention because I want to cure people, not harm them, you know.
I would just like to add some information to just a location. An interesting location is in Perth, in Scotland, in the place called Scone Palace.
Yeah, I know Scone.
Okay, and Scone Palace was where the actual kings were throned. The Scottish kings were throned. And that's where the stone from Scone comes, which is the official coronation of every king of England or queen of England.
Allegedly.
Yes, allegedly. But the area where the actual coronation took place, soil was taken from all the different participants in different areas of Scotland, and a small mound was built.
Oh, really? Oh.
Where all the soil was collected from the different, everybody had to bring the soil and build the mound to where this coronation took place. So actually where the stone from Scone originally was, close to the church, is where all these soils from all different parts of Scotland came from.
Yeah. No, I know about the Stone of Scone because it was stolen in the 1950s by an ex-MP called Tam DL, and they buried it in a field, and they were hunting for it for, I can't remember, half a year as a protest about Scottish independence. And then they told the police where it was, but that's if they gave the right stone back. That's why I know it, because there was always a debate, is this the right stone? I'll never get the real stone, and you've not, and all that. But that's really interesting about all the soils gathered together, because I do actually do some other work on, you know, what's in soil and what do the other microorganisms do in soil, you know. So that's also for like carbon budgets and nitrogen budgets and, you know, green things.
Which is quite interesting because the soil in Scone Palace and also several of the other palaces is very fertile, because that's where they have these gigantic sycamores and the gigantic Canadian reds and all the different other gigantic, you know, nearly sometimes prehistoric trees.
Yeah.
that grow in the surroundings of, or in the garden there.
Yeah. Well, I know in Perth, actually, they have the tallest hedge in Britain or something. It's huge hedge. I can't remember how many feet it is. So. I've heard anyway.
Yeah, and one of the biggest fish was also caught there that was recorded. It's in the museum there, in the local museum, photos of gigantic fish. So the water and the soil is quite.
I don't spread to fish. I don't spread my diversity, but I am interested in many things. You know, I like to cross pollinate. You know.
Maybe going back to soil, because some of the stuff that has been mentioned just now actually leads to a question I have about the soil that has been frozen and is now being unfrozen by climate change.
Yeah,
I read all kind of stuff about bacteria that has survived there for tens of thousands of years.
Yeah.
And now, how do you judge the potential of that in a positive or negative way? What do we have to expect?
Well, I think you know.
Will we all die?
What they say just now is we've only discovered 1% of bacteria that actually exist, you know, and maybe that's, you know, because I've been experimenting with different ways of growing bacteria, and they say genetically you can find the other 99%, but I think that's a bit far from the truth, because actually they haven't developed. We are using the same techniques, the same lab techniques that they used 100 years ago for isolating bacteria. You know, the same techniques that Fleming was using. We're still using these agar and stuff, you know. And although they have more techniques, they never really studied, you know, minerals and crystallography and stuff to see what, you know. Just now, the biggest thing in bacteriology is the space bacteria grow in makes them do different things, you know. So on an agar plate, the bacteria behave in one way. It's a flat surface with so many nutrients. But in a 3D soil structure with a different, they produce different things. So, you know, one of the things in my research is to produce conditions as close to the original conditions as possible. Because we know with Streptomyces, and this is what's interesting about being found in a graveyard, they have what's called a cryptic metabolites. And cryptic metabolites means that really the Streptomyces might have the capability of producing 30 different substances, antibiotics, maybe anti-cancer, maybe antiviral, okay? But it only produces like 1 or 2 of them because the other genes haven't been turned on by different kind of ecological pressures, like maybe stress or starvation or stuff, you know? So, sorry, I'm deviating from the point, but one of my jobs is, and other researchers that I know, is to awaken, you know, expression. That's the biggest thing in biotechnology, awaken expression of hidden gene clusters. But back to the Siberian, because I do collaborate, or I do some discussions with some people in Siberia. I think it was Lake Baikal or something. I can't exactly remember the name, but they do some fabulous research with shrimps in the bottom of the lake, and they isolate some Streptomyces from their gut that produces really, really weird antibiotics, you know. But you know, there's such a diversity of bacteria. I don't, you know, the pathogens we have just now are successful because they've had thousands of years with us. You know, if you put your hand in the soil, apart from maybe something like anthrax, you don't really have to worry a lot about being infected. The pathogens that infected us are mostly adapted to us. The virus that infects us is found a way to be adapted to us. It moved from one animal to another animal, not a plant. You know, so mostly plant pathogens only affect plants, and some jump occasionally, but it takes them a long time. So something found deep in the sediment is more worrying to the human imagination, I think, than it is to worrying to humans. You know, it's good for a story. I know that media love big stories, and they love to shove the fear factor up. but I don't think we really have. I think it'll be very interesting actually to discover, you know, they actually were doing experiments on some of the islands, isolating streptomyces from some of the islands where they used to do atomic tests, you know, and I think they discovered some longevity compounds or something from some of the bacteria there, you know, some of the streptomyces here. So, you know, there's a whole load of potential. I don't see it as frightening or awakening some demon from the crypt. I see it as unlocking something that, you know, maybe helps humanity. We do have screens for dangerous things. You know, we do have toxicity tests and for anything that comes into a lab. So I'm not frightened. I'm more excited than frightened, you know.
Fascinating, Gerry. So we don't have to fear for the ice caps melting and having some new killer bacteria.
That's a great story for the newspaper, isn't it? Well, what were the bacteria doing? Were they infecting a mammoth, or were they just, you know, were they just hanging around a plant or just living in the soil? I mean, if you take an organism out of its environment, it will do something different, you know. And I'm sure they're quite happy in the soil. They don't want to come to, you know, I said Streptomyces evolved with plants. You know, they evolution, well, so to say, sorry. Evolutionary, they developed 300 million years ago with the development of land plants, and that's what they like. You know, they're really just adapted to breaking down complex macromolecules. You know, so I doubt if anything in the soil. You know, most of the organisms that infect us, like Staphylococcus aureus or Pseudomonas, or you know, some of them they call opportunistic infection agents, but other ones. When I was in Florida, I studied Staph aureus, and I studied 100 species of Staph aureus, all nearly genetically identical, and I studied the most successful ones. What did the most successful ones do? Well, the most successful ones were being involved with humans for quite a long time, and they were well adapted to tricking the human immune system, you know. So, and you know, everyone forgets about human immunity. We have like 10 systems of defense before, you know, something really gets to us. We have our innate immunity, and you know, we have adapted immunity, and you know, on and on.
Good. Well, let's hope we survive this one that we're faced with right now with COVID.
Yeah, I don't want to get into a long discussion. There's like every inch of airtime is taken up. So and maybe rightly so, but this is it's not about the virus just now. So next one will be the virus.
Well, I hope you'll keep us abreast of your developments there as you make some great breakthroughs.
Yeah, sure. No, I'm you know, like I said, I really like listening to other people's perspective, because that, you know, the perspective always helps you see. It helps me try and explain. You know, I wouldn't have added in. You know, some of the drug development companies were really important in bringing antibiotics. You know, some of the pharma companies were really essential in bringing antibiotics to the masses. You know, but I wouldn't have really looked into that so much. I kind of knew it, but if I didn't know I had this talk coming up, you know, and I thought, well, it's a business organization or something, so I wouldn't have really been really interested in what was going down, you know. But you know, I like talking to different audiences, and you know, trying to see things from different angles, because then you get to see the whole elephant, you know, as they say.
Well, we have our envoy there in Ireland, my sister, that lives just around the corner from you, so she'll keep in touch with you.
Yeah, she can tell me what the rope was made out of first. You know, that's my first mission. And where did she get the clay? Well, you know, that's
secret.
That is, you know, I'm really interested in holy places in Ireland. You know.
Well, there are a lot of them out here, because
yeah.
This is St. Columkille's. Have you heard of St. Columkill?
Yeah. No.
His birthplace is just right out the road here.
I'm really interested in like the rocks and the clays around them and stuff, to see, is there any Streptomyces? You know, that's number one. You know, can you tell me?
Top
Have you-
secret.
Have you got a microscope?
Well, that's interesting, right? Because you're definitely bringing the scientific method to these traditional handed down cures, right? This is interesting.
Well, you know,
to
I mean, I
document in
think,
this sense.
you know, I think it's all very well to think they were modern, developed, and superior, you know, but some of these conditions were taken care of years ago before they knew what, you know, what they were actually doing. And it doesn't mean to say that we just discard, you know, some ancient knowledge. You know, I look forward to the deciphering, you know, some of these with the help of other people. I think there's a whole department down in Trinity College, you know, that they have tried to assemble them, but maybe, you know, maybe their specialism isn't streptomyces or anything like that, you know. So, but they converge along similar lines to what I do, you know. But I just need to, you know, find more things to. But so this is my ultimate problem, okay? And the problem I'm facing now is if I find a place and I discover a streptomyces, right, and it does good things and I develop compounds, do I tell anybody where I found it, you know? Because from my previous one, I know that there'll be, I had to write to the editor of the magazine on my last publication and says, I can't tell you exactly where it came from. You know, I can tell you within 10 miles, but I can't, you know, and I can't name a well, I can't name a stone, you know, in case, you know, the whole thing is, the environment is ruined or desecrated or anything like that, you know. So, and now I probably won't tell you which half of Ireland is in, you know, is in the north or which county. I can't even say that anymore. So that's my current dilemma, because most scientific magazines ask for accountability, and you really have to prove what you did. But geographically now I can't, you know, I really can't say anymore, because it kind of ruins the cure or the place for a lot of people. So I really don't want to, you know. Anyway.
Thanks so much, Gerry Quinn, joining us from Southern Ireland, the southern tip, right? That's where you are right now.
No, I'm in Northern Ireland, from the north of.
No,
Northern
you're in the south.
Ireland,
We don't want to throw people off the trail there.
Oh, yeah, see, yeah, sorry, I didn't catch the humour there. Right, went over my head. Yeah, that's right. There's nothing beside the Giant's Causeway anyway. Nothing to see.
Fascinating stuff that you're working on. So glad that you could come with us. Thanks to Niels Winkler, our fellow board members, for finding finding your some of your publications, and then contacting you, and having you actually come join us here. It's been a real treat. It's been a bit of a break from our normal politic heavy talks that we've had this last half of the year. And speaking of that, next week we'll be back to Brian Rigg, historian that we had on also in the fall, a fascinating fellow who wrote 5 publications. One of them was called Hitler's Jewish Soldiers, and he will join us on the 4th of February, just a few days before the beginning of the second impeachment trial in the Senate, which is supposed to begin on the week of the 8th. So, Gerry, you're also welcome to join us if you feel like stepping into that puddle.
Controversy.
Yes.
Controversy. No. Science and folklore are hard enough. It's a hard enough ship to sail, you know. So.
Yeah. Well, we have Brian Rigg. He'll give us a very objective view of what both sides are preparing for, the Democrats and Republicans, and sort of an analysis of before the event. So that will be next on the 4th of February, Thursday, at 7:30 p.m. German time. And look forward to seeing any of you, all of you here. We see Dorothy. You can, if everybody wants to put their video on and say goodbye to Gerry and thank him for being here, you can put your microphone on as well. Thanks so much, Gerry.
Thanks.
Yeah.
Thank you, Gerry.
Thank you.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.
My pleasure.
Bye-bye.
Take care, everyone, and hope to see all you soon. Stay safe. We'll talk to you later.
Bye.
Bye-bye. Bye
Bye.
from the American
Bye.
Club.